Hi children, good afternoon. Today we are talking about circles. Chapter 9. We will cover the exercise 9.1 and 2. 9.1 is nothing, but 9.2 is important. One is important, but that is only the theorem. 9.1 you can see theorem 9.1. That exercise is also based on these two things. Equal chords of a circle subtend equal angles at the center. Let me share the screen. You will understand this. Look here. Yes. Circles continue. That means before also we discussed about circles. Many things: chord, segment, sector, diameter, arc, many things. Anyway, today it is very nice. 12, 12, 24. Very important, very interesting, I can say. 12 plus 12, 24. Can you see this one? 12, 12. You can remember the date. 12 plus 12, sorry, that is equal to 24. Yes, 12 plus 12 is 24. That is the date today. 12, 12, 20. Fantastic, I can say. Good. Now listen. 9.1 equal chords of a circle substance equal angles at the center. What is it? I think it is not the equal chords of a circle. It is a circle. Sorry, circle. Almost I can draw like this. Okay, great. Center of a circle. Equal chords of a circle. That means suppose this is one chord and this is another chord, but both are equal. Suppose this is 6 centimeter. This is also 6 centimeter. This chord I am talking about. Then the angle made in the center. This is of this angle and this angle. Look here. This angle will be equal to this angle. That means that is correct. That is correct. If this is, suppose this is 70 or 55, this angle is also be 55. Suppose this chord is again 6, so it is 55. Equal chords of a circle subtend equal angles at the center. We can draw many chords. Chord is the line segment whose endpoints are on the circle. We study diameter the longest chord. Okay. Now listen here. Next to one. Theorem 9.2. That is a converse. Converse is not new for you because we did many times. We explained many times converse. We did many times. Same thing in a reverse way. That is another way. If the angles subtended by chord of a circle at the center are equal, then the chords are equal. Here again the circle is there. Here one chord is here. Another chord is here. But these angles, look here. Y is the center. A, B, and C, D are the chords. So what do we observe? This angle and this angle, that is 60 and this is 60. Then this chord AB may be 7 centimeter or 70 centimeter or 8 centimeter. So both are same. If the angles are same, chords are equal length. If the chords are equal length, angles are same. Both are always one. I think there is no confusion. Any confusion is a placing point. You can interact in the channel itself in Math Lab. You can ask the question. You're always welcome. Feel free and ask question. Anything, any queries you can ask. Maybe I am wrong sometimes. You can correct it. Doesn't matter. Now, page number 118, 121 in this book. Okay. After you can see 9.1 exercise. I am not doing that because it is same theorem. It is there in the textbook. We call that two circles are congruent. They have the same radius. Prove that equal chords of congruent circles substitute equal angle of the center. Two congruent circles. So exactly same thing. Two congruent circles. So same thing because congruence means exactly same. So equal chords substitute equal angle of the center. That we can prove because two triangles are congruent. So CPCT we are doing this one. You can see two triangles. Chord 6 is equal to 6. The radius is equal to radius. Two radius. SSS congruency, you can prove that. Okay. Now, something from the chapter, what I noted. The length of perpendicular from a point to a line is distance of the line from that point. Suppose here is a point here point P. Distance means, see, here is another line, another spot is there. What is the distance? Distance is not this one. Distance means perpendicular. It will be 90 degrees. Always remember that. The length of the perpendicular from a point on a line to a line is the distance of line from that point. Distance P to Q. Suppose this is 5 meter means perpendicular distance. So you know it is not 5, it is more than 5. It is not perpendicular distance. It is not perpendicular distance. Perpendicular means height, that is the distance. It is not the distance. Okay, distance means perpendicular between two lines or 2 points. The distance, length of perpendicular from a point to a line is the distance of the line from the point. And distance of a line from the point means that is perpendicular. Smaller distance, that is perpendicular, 90 degrees. The perpendicular from the center of a circle to a chord bisect the chord. I explain what is perpendicular. Now 9.3. Perpendicular from the center of a circle. Again, the circle is there. Okay, this is the circle. Center of the circle. To a chord bisect the chord. Great. Here is one chord. So this is the O. If you are drawing perpendicular 90 degrees, it will bisect AB. Suppose AB is 8 centimeter. So 4 and 4 bisect we cut into equal parts. OP is the perpendicular. If you are drawing the perpendicular from center to the chord, many chords are there. So it will be half and half. Bisect the chord. Okay. The line drawn, same thing. The line drawn through the center of a circle bisect the chord is perpendicular to the. This is the converse. I can say this is the converse. Converse of 9.3. Correct? Converse. Here the line drawn through the center of a circle. Yes, again the circle is there. From the center, a line is drawn to the, what I can say, that line is drawn to the chord. A chord is here. But center of circle, center to bisect the chord. Suppose this is 5 centimeter, 10 centimeter chord. Chord AB is 10 centimeter here. So if you are drawing to the middle, then it will be 90 degree perpendicular. Nothing. Before what I told, a line segment perpendicular to the chord bisect the chord. Now, if a line segment from the center bisect the chord, that is perpendicular. Anyway, that is converse of this one. Any confusion? No confusion. If any confusion, please inform. This is all a simple idea. That is why I am rushing. Nothing is there. But understand, it is the first time we are hearing these laws because No, sorry, you need this one in class 10. There you can see you studied in class 9. Class 6 also we study many things about the circle. That another video I did. You know that. Team as that. Now equal chords of a circle or a congruent circle are equidistant from the center or sundays. Equal chords of a circle are equidistant from the center. Before that we said equal chord make equal angles. Now equal chords of a circle of a congruent circle or congruent as I am drawing a circle. You can draw congruent circle. Again, the circle is the equal chords of a circle. So I am drawing one chord here. This 10 centimeter, another chord here, 10 centimeter. This is AB. This is CD. Equal chord. Both are equal, sir. Are equidistant from the center? Yes. Center, distance means perpendicular. This is the distance. And this is the distance. It will be 90 degree. It will be 90 degree. That means this distance will be equal. I told you chords 10 centimeter chord. Maybe this is 5 centimeter, 5 centimeter, 6 centimeter, 6 centimeter like that. Suppose the chord, the distance may be 6 centimeter, no problem, 6 centimeter. X centimeter, X centimeter. Equal chords of a circle are equidistant from the center. Distance is center. Distance from the center. Center distance is a mile. Chords equidistant from the center circle are equal in length. That is converse. This is a converse. I can say converse of 9.5. One study, another one free. Offer on 9.5 to converse. Chords of equidistant center of circle are equal in length. Circle is the, as before, circle is the, chords are the chords of equidistant from center. Okay. One chord is the distance is 5 centimeter. Another chord is here. Distance also same. Distance be perpendicular distance. So the chords are equal. Chords of equidistant from center of a circle are equal in length. Any confusion in the placing, please. Okay, so we can do almost same. This is the center. Equidistance, that means chords are same. Converse of that. Now all of you please listen. Circle axis is 9.2. I told you 9.1, two things are the same law, same theorem, congruency of circle we can prove. Now see the question. Figure is not given that your textbook. Okay. Two circles of radii, 5 centimeter, 3 centimeter, intersect at 2 points. And distance between them. 2 points, you can see two circles intersecting 2 points. A and B, you can see 2 points intersecting 2 points. And the distance between the center is 4 centimeter. This is 4 centimeter, not 5 centimeter. Up to here, 5 centimeter. Because it is the radius of the circle. Up to here. Up to here, it is 4 centimeter, not 5 centimeter. Sorry, not 5 centimeter, 4 centimeter. Distance between the centers. One is a big circle, 5 centimeter, another the small circle, 3 centimeter. Find the length of the common chord. What is the common chord here? You can see AB is the common chord. AB is the common chord. Yes. Now look here. This common chord AB is the two circles that will pass through the center. Now we can say this angle is 90 degree. 90 degree. RHS congruency you can prove. Look, Here, we had to find out AO and OB. Okay. Distance. One thing you know, bisect the chord. O dash bisect AB because it is perpendicular. 90 degrees. So we can say here AO square, that is equal to, from the right triangle AOB, right? From the right triangle. From the right triangle AO, a triangle AO dash. What is it? AO dash square is equal to, what is it? O dash square plus AO square. We need AO. That means AO square is equal to O dash square minus, no, sorry. Listen. This is AO square. AO dash square minus O dash square. Yes, O dash square. We need AO. So what is this? Pi square minus 4 square. That we know 25 minus 16, that is 9. So AO is equal to root of 9, that is 3. Root 9, that is 3. You got it? A is equal to 3. What is the question? Look at the question. Find the length of the common chord. So chord is equal to AB. You can see in the figure. AB is equal to 2 into 3, that means 6 centimeters. That is all. Like this you can do, because you draw this center chord is here like this common chord, and this two triangle, we know the right triangle, we got AO, double of that will be AB, the common chord, because bisect the chord, it's a perpendicular shorter distance. I think you understand. This is one method. Another method is the like this we can do as the radius of the bigger circle AB. A is the midpoint of AB. So bigger circle, the distance between the center is 4 centimeter, and midpoint bisect the chord, so 6 centimeter. All of the pay look this also. O dash is the perpendicular bisector of AB. So O is equal to OB is equal to OA is equal to OB is equal to. We got that is 3 centimeter, 3 centimeter. Like that also we can. Now next question. If two equal chords of a circle intersect within the circle, through the segment of one chord are equal corresponding segment of other. This figure is not given in the textbook. If two chords of a circle intersect within the circle. Second figure is not given, third figure is given. If to a chord of a circle if two chords of equal chords of a circle in the set within the circle prove that the segment, the line segment, the segment of the one chord are equal to corresponding segment of other chord. What do you mean by segment? Don't confuse here. It is segment is part of a chord. That means here you can see AB is a chord and CD is the chord. That is here the segment A you can see. We have to prove A is equal to ED. It's a part of a chord. Don't think segment is in a circle, area between the chord and the R. So here, segment of the chord, not the segment of circle. So A is equal to D, we have to prove, or EB is equal to EC. That will. For that, take do like the join the center, perpendicular, bisect. So we are getting RHS, right to right triangle, first triangle and second triangle. First is OME and second is ONE. We can see this is OM is equal to ON because two chords are equal. In the question it is that two equal chords. Distance from the center will be equal and perpendicular. So we can say here OI is equal to OE. Then what is that? Then OM is equal to OM. Correct? Then OE is equal to OE. We got it. RHS congruency, we got it. OE is equal to OE. OM is equal to ON. RHS congruency. So from that congruency, what we can prove? Prove that the line joined in the point of intersection to the center make equal angles with the chord. Oh no. Prove that the segment of the one chord are equal to corresponding segment of other. We know AM is equal to ND. And now we proved M is equal to NE, CPCT. So AM plus ME is equal to DM plus NE over equal. Segment is equal. Now we can say EC is equal to EB. Equal from 1 to 3. Because D is equal to A. So we can say EB the left. Suppose this AB is 10 centimeter up to AE. This is 7 centimeters. Also 7 centimeter. So it is 3 centimeter, 3 centimeter. Only logical. It is the difference. All of you please look here. You can take a screenshot. I think you understood this. Now next question. Okay. Third question. Is it? If two equal chords yes. Third question also now figure is only one figure is that exercise. If two equal chords of a circle intersect within the circle. Yes. No. Intersect within the circle. Both are safe to equal chords. If two equal chords of a circle intersect within the circle, prove that the line joined in the point of intersection to center make equal angle with the center. The chord. Here only the difference. Look here. Figure is saying no confusion. Same figure. Same figure. Listen here. Chord is down only. That is the only thing. Here also we had to prove that angles are same. Consider the triangle OEM triangle. This is the triangle 1 and OEN. OEN is the second triangle. This one OEN. These two triangles are congruent. of course. Because as before, OM is equal to ON, then OE is equal to OE, that means common, RHS congruency. So, which are the, yes, angle OME perpendicular and CPCT. MEO is equal to NEO. Back BUQ is equal to CEQ, BEQ. So what is that BEQ? This angle is same thing. MEO, no? MEO, that means BEQ, that is equal to this angle. That is proved. Small triangle or big triangle. Suppose this is 60 degree. Then we study that. This also, suppose this is big. This is also 60 degree. There is no confusion. What are 60 degree from here on? Okay. So hence prove MEQ is equal to NEO. MEQ is equal to NEO. MEQ is equal to NEO. The MEQ is equal to BQ. And NEO is equal to Q or CEQ. That is it. Logical one. Now look here. Fourth one. Figure is given. If a line in the set to concentric circle, what do you mean by concentric circle? Concentric circle. What is concentric circle? That means through one center we can draw many circles. They are called concentric circle. Radius R, radius R2, radius R3 like this. R3. Or this is R. This is small r. This is R2. Many circles we can draw. Concentric circle. Now two concentric circles. So circle with the same centers. O and BC prove that ABC is equal to CD. Look, figure is given. You have to prove AB is equal to CD. So what do we think? AB is equal to CD. What the condition? If a line has two concentric circles with the same center with O at ABC, and D, prove that AB is equal to C. AB is equal to C. മോളെ പിന്നെ അമ്മച്ചിന്റെ കുഴപ്പം ക്ലാസ്സിൽ concentric circle, you understand this. Sorry for the interruption. You can see the concentric circle. Now look. You have to prove AB is equal to CD. That's all. Now line segment from what to is at OM perpendicular to, see here, OM perpendicular to. OM is bisecting AD. AM is equal to MD because perpendicular bisect the chord. Like that AM is bisecting BC also. OM, so BM is equal to MC. Because AM is equal to MD. AM is equal to MD bisecting. Second here, what is BM is equal to MC. BM is equal to MC. This is BM. BM is equal to MC. Okay, fine. Now what you have to prove? What you have to find out? Prove the AB is equal to CD. AB is equal to CD. That is correct. AM minus BM. AM minus BM is equal to MD minus CM. What is AM minus BM? AM minus BM is equal to AB. And MD minus MC is equal to CD. That is that. Nothing is there. Yes. Equation 1 and 2 equal to AB is equal to CD. AB is equal to CD. There is no confusion. Now next one. Now 5 and 6. Lengthy question that 5 and 6. Okay, 5 and 6. Here. For examination point of view, they will not ask this question, big question. Anyway, three angles, Rashma, Salma and Nendo are playing game by standing on a circle of radius 5 centimeter. Radius of circle OI is equal to 5 centimeter. If the distance between Rashma and Salma and between Salma and Mandeep are 6 centimeter, each what is the distance between Rashma and Mandeep? Okay. So, this is given. Standing on a circle, radius 5. That means this is 5. This is 5 centimeter. Reshma throw a ball to Salma. 3 girls. Reshma. This is Reshma. And this is Salma. And this is Mandeep. Playing game by standing on a circle of radius 5. Now, and Mandeep, if the distance between Reshma and Salma and Mandeep 6 each. Reshma and Salma, this is 6. This is the distance. This is the distance. And Reshma throw ball Salma and Mandeep to Reshma. This means Reshma and Salma, and between Salma and Mandeep. Salma and Mandeep it is given. Salma and Mandeep is also 6 centimeters. 6 is meter. What is the distance between Reshma and Mandeep? Reshma and Mandeep, this distance. That is AC we have to find out. Okay. So how can we do AC? Here. Okay. So many things are many methods are the one method you can find out like this, and you can take screenshot. Another method also there. X and Y we can give pi minus x, then applying Pythagoras theorem. Y is equal to m square plus am square. Equals c square is equal to like that. Triangle OAM. We are taking the triangle OAM. 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 Okay. AB square. Anyway, like this, we have to substitute like this. We are getting the distance is 10.6. Now, all of you, please listen next one. I know Day after tomorrow is the Christmas exam is there. This question no chance because big question. Because you have 3 lessons, I think so. Circles, quadrilaterals, and triangles, right? Now 6. A circular park or radius 20 centimeter situated in a colony. 3 boys and David and Gore are sitting at equal distance on this boundary, each having a toy telephone in his hand to talk each other. This question, because this book is made, printed before 20 years. That is why that time there was no mobile. Like the mobile was there, but not like this. In 2000, So that is why toy mobile also, that now the mobile have no toy telephone hands to talk each other. Why the length of the string each for? String on the but now no string is there because mobile, only Wi-Fi or something like that only. Anyway, for that time that string ഉണ്ടാവും ടെലിഫോൺ തന്നെ വയർ ഒക്കെ ഉണ്ടാവും അധികം ദൂരം ഒന്നും കൊണ്ടുപോകാൻ പറ്റില്ല. Draw a diagram and the diagram. Angur, Said and David are requested A, B, C respectively. A, B, C. Very good. A, B, C. Anger. This is Angur. B. And B side. Then a side. B side. C is not cat. C is David. David. Very interesting. So what is given the equal distance? The triangle ABC will form an equilateral triangle. This is an equilateral triangle. Equal. So these we can see equilateral triangle altitude median. That means incender is the incender. You can see this one. AD is the median, AD is the altitude for the equilateral triangle. Even though the median is the middle point from vertex to the opposite sides of a triangle, line joining the distance from middle to the vertex. Altitude is the distance from vertex perpendicular to the opposite. Both are same here, equilateral triangle. And this will be 2:3. 2:3. That means 2/3. 2/3. 2/3 will be this AO. 2/3 of AD will be AO. There's a concept like that in center. Okay, we can check. Equal distance ABC will form equilateral triangle, AD perpendicular BC. And now AD is the median ABC. Yes, middle point. Passes through center and also is the centroid. The name is the centroid and orthocentroids. OA is the radius of the circle. OA radius of the circle 2/3 AD. See, this AO will be 2/3 AD. AO is the radius of the circle. That is the law. Now that concept we are making. Apply Pythagoras theorem. AB square is equal to AB square is equal to BD square plus AD square. So what is AD square? That means AB square minus BD square. Then A, we are giving this is A, then A/2, like this. Put this is A, so this will be A/2, here also A/2, because total is A. Middle point of equilateral triangle. Then Pythagoras theorem applying, we are getting 3. AD is equal to √3 by, we are AD. We are taking the square root of √3. Here you can see AD square, we got this one. Then square root of 3, A, square root of 3, A square, square root of A, I am talking A, this one about A. What is square root of 4? By 4, no, √3. Actually, this is A square, root of A square by root of 4 because we know the laws. What is root of a square? AD. I'm talking about AD from here. AD is equal to square root of a square is a. Root 3 is root 3 by 4 means 2. That is root 3 by root 3 into a by 2. Correct? Root 3 into a by 2. So OA is equal to, we know OA is equal to 2 by 3. 2 by 3 AD. AD is how much? So I'm giving 20 root 3. OA is equal to 2 by 3. 2 by 3 is AD. We study this one. In center is 2/3 of the median. So 2 by 3 into AD is root 3 into A by 2. Correct? We are getting. Here, the same thing. Don't count with root 3. We are talking about root 3. A by 2. Root 3 into A by 2. Yes. Now 2 by 3 of, here I am doing this one. 2 by 3 into root 3 into A by 2. This 2 to cut. Yes. 2 by 3. No, sorry. 2 by 3 into root 3 by 2. Yes. 2 to cut. What is here? 3. Here we got what is 20m. Or we got from here. That means 2 by 3 root 3 AD. That means A over O is equal to, look, 20 meter in the colony. A circle of radius 20 meter. So the radius, we know that is 20 meter. What is the radius? OA. Yes, O is 20 meter. So we can make this one. OA is equal to 20 meter is equal to 20 meter. Now what we are getting here? Now 20 is 3 and root 3. What we can say? It will be root 3. Root 3 into root 3. So 20 root 3 A 20 root A is equal to. Now look here. We got here 20 is equal to A by root 3. Not 9, this one I'm confusing. This is A. A by root 3. So A is equal to, it is A is equal to 20 root 3. That is it. I think you understood this one. So calculation is there. So understand what is going on here, what you applied here. Then we can see this is the median, orthos median is there, middle altitude also same thing. In center is 2/3 of the AD. That means radius A is equal to 2 by 3 of AD. Again. Okay, then I think you understood. Any doubt you can ask me. Feel free and interact. Thank you. Tomorrow we can see each other.